composition of the atmosphere, diatomic nitrogen, oxygen, water vapor, and argon make up roughly 99.95% of the atmosphere. The other 0.0% of the atmosphere is made up from carbon dioxide, methane, nitrous oxide, ozone, and halocarbons. Greenhouse gases are referred to as the gases within the atmosphere that can absorb infrared. This includes water vapor as well as the 0.0% stated above.
The carbon cycle describes how carbon cycles through its primary reservoirs. The atmosphere exchanges carbon with the land through photosynthesis and respiration. The atmosphere exchanges carbon with the ocean when carbon dioxide dissolves in the ocean. Once in the ocean, carbon dioxide is converted into carbonic acid. Over a long period of time, a carbon atom will cycle through all of the reservoirs, including rock reservoirs, which is done through volcanism and chemical weathering. Here we have a table explaining the reservoirs and how much quantity of carbon in gigatons there are respective to each reservoir. It also shows us how long carbon will stay in this reservoir in a rate of gigatons per year, and then it also shows us which pathways carbon will take towards its next reservoir once it exchanges its primary reservoir. So for the atmosphere, there's a total of 850 gigatons, and if it's going to the upper ocean, it will take about 80 years to cycle through that, and if it's going to the land biosphere, it's going to take 120 years for a gigaton to go into the land biosphere. The upper ocean reservoir has a total of 900 gigatons, and it will take 80 years for one atom of carbon to reach the atmosphere and 100 years for it to cycle to the deep ocean. Once in the deep ocean, there's about 400,000 gigatons of carbon at a exchange rate of 100 years for 1 gigaton to reach the upper ocean. In sediments is our largest amount of carbon, holding over 100 million gigatons of carbon, and it takes about 0.1 years for it to reach the atmosphere through volcanic eruption. And on land, there is about 2,500 gigatons of carbon at an exchange rate of 120 years to reach the atmosphere. Human effect.
Okay. Carbon dioxide vary without any human activity. Human affected on carbon cycle by digging up and burning fossil fuels. This has caused the release of carbon from the rock reservoir in a pace much faster than natural, and has added carbon to the cycle that would naturally not be there.
So why is carbon dioxide the most concerning? Carbon dioxide will take hundreds of thousands of years for the carbon that we as humans have added into the atmosphere to dissipate from the carbon cycle. Therefore, even if we stopped burning fossil fuels right now, we would have made a lasting effect on the climate of our planet for hundreds of thousands of years. So carbon dioxide can be chemically footprinted to show that it comes from fossil fuels with a method that is based on isotopes. Because the atmosphere is depleted in carbon-13, we know that the extra carbon dioxide is not from the biosphere, and because the atmosphere is depleted in carbon-14, we know that the extra carbon dioxide is not from a volcano. Also, combustion uses oxygen, therefore we know that the extra CO2 is from humans because oxygen levels in the atmosphere have dropped.